So let's talk about side, side, side first. The side, side, side congruence postulate is a postulate. It's something that can't be proven. So there is no proof to this. It's something that we assume to be true. But it's a logically good assumption to make. Now, let's read what it talks about. It says, if three sides of one triangle are congruent to three sides of another triangle, then the two triangles are congruent. Notice the hypothesis follows the if. Three sides of a triangle are congruent to three sides of another triangle. That's the hypothesis to this postulate right here. The conclusion is then the two triangles are congruent. And so that part right there is the conclusion. So let's make some givens here. I'm going to take the three sides of this triangle here, and what we're going to do is we're going to make some values congruent. So let's say that AB is congruent to DB. So this side matches this side. Now let's say that AC matches DC. Now, I can stop right there because these two triangles now have to be congruent. And the reason is because BC is the side that they have in common. So this right here is congruent to itself, and that's called the reflexive property. So side, side, side congruence is a postulate that helps us know whether two triangles are congruent by just looking at their sides. If we didn't have side, side, side as a postulate, then we would actually have to take the time to show that all the corresponding sides are the same, and we'd have to show that all of the corresponding angles are the same. But we don't have to do that now. It actually cuts our work in half. Okay, let's use side, side, side congruence to show that triangle ADC is congruent to triangle CBA. This is going to be pretty easy because all we have to do is to show that AC is congruent to itself. Since AC is the side that links up the two triangles together, we can say that AC is congruent to AC because of the reflexive property. So now all three corresponding sides, sets of pairs, AD matches CB, DC matches BA, and AC is congruent to itself. So we can finally conclude that by side, 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 the two triangles are congruent. Okay, in this example, we're going to verify some triangle congruence. And so what we're going to do is we're going to show that the triangles are congruent for the given value of the variable. And so in this case, we're going to let x equal to 3. Okay, so for the given value of this variable, we know that triangle UVW is congruent to triangle YXZ. What we do is we follow the letters. U corresponds to Y, V corresponds to X, W corresponds to Z. So segment UV, which is right here, corresponds to segment YX, which is right here. And that means that the value of 4 needs to equal 3x minus 5. What I'm going to do is I'm just going to plug in the value of x into these three expressions right here. So let's just go ahead and do that real quick. 3 times 3 minus 5, well, that's equal to 4. X equals 3 is just 3, so xz is 3. 3 minus 1 equals 2. So what we end up getting is we end up getting this side here is 4. We end up getting this side here is 3. And we end up getting this side here is 2. So since zy, look at where it's located. Z is at the end, y is at the beginning. So zy should correspond to wu. Well, wu is here, and so that's 2. So they all match. So we've just verified that the two triangles are indeed congruent by the side, side, side postulate.